Welcome to GER of Mathematics and Statistics lessons. In today's video, we shall be looking at the theory of quadratic equations. So this is not the first video we've made on quadratic equation. It is actually the second video we shall be making on quadratic equation. The first video we made on quadratic equation was about a part 1, episode 1 approach to theory of quadratic equations. What did we discuss in that video? We looked at what a quadratic equation is. So we answered the question, what is a quadratic equation? We also answered the question, when does a quadratic equation cease to exist? And also we looked at mentioning 3 techniques for solving quadratic equations. So those are the 3 things we discussed in the part 1, episode 1 on the theory of quadratic equation. If you want to know more about what we did, please click the link in the description below. Okay, in today's video we shall be looking at using the 3 techniques we mentioned in that video to solving problems in quadratic equations. So solving quadratic equations. So I'm going to begin in this video with the scissors technique, otherwise known as the factorization technique or trial and error approach to solving quadratic equation. Thereafter we shall look at the completing the square technique, and then finally we shall visit the quadratic formula technique for solving the quadratic equation. So let's begin with the first technique, which is the scissors method. So come with me. Now, let's start with understanding how to use the trial and error technique, okay, otherwise known as the factorization technique. So how do you use this method? I will be listing out steps. In other words, I will be giving you an algorithm for solving problems in quadratic equations or quadratic equations using the factorization technique. So let us outline the steps useful for solving the quadratic equation with the scissors method or factorization method. So I'm going to put here algorithm or steps for solving quadratic equations with the factorization technique. So that is what we shall be doing first, okay? Now, let me tell you something. The algorithm is a sequence of logical mathematical steps useful for solving problems that are tractable, okay? So I'm going to be listing out the steps for solving quadratic equations using the technique called the factorization technique. Now, what does this technique involve? Let's start with step 1. So if you are to solve a quadratic equation using this technique, step 1 will be to look for two numbers whose product gives the product of the first and last terms in your quadratic equation. So this will be the first step. This will be the first step used in this approach for solving the quadratic equation. Again, what is the step all about? It requires that you should look for two numbers that will multiply to give you the product of the first and last term. Now, once you can do that, you can move over to the step 2. Now, the step 2 is tied to the step 1 because the step 2 says the same two numbers must add to give the middle term. Okay? The same two numbers must add to give the middle term. Now, just in case you do not know what I'm talking about and you've not watched the first part and first episode of the quadratic equation, then I would want you to look at what we are talking about. Okay? So, what are the first and second steps all about? The first and the second steps are all about showing you how to use the quadratic equation for solving how to use the factorization technique for solving quadratic equations. So the first step requires you to look for two numbers whose product gives you the first and the last term, the product of the first and the last term. And the second step requires that those same two numbers you found in step 1 should add to give the middle term. Now let me show you what that means. That means that if this is our typical quadratic equation, ax squared plus bx plus c in the variable x, we will be looking for two numbers whose product will give the product of the first. This is your first term and this is your last term. Okay, so if this is your first term in your quadratic equation, and this is your last term. Okay, so the number we are looking for, the two numbers we are looking for are numbers that will multiply to give ax squared times c. That is, if we multiply those two numbers we are looking for in step 1, they would multiply to give acx squared. Okay, now the same two numbers we are looking for must add up to give us this middle term. So this is the middle term we are referring to. This is the middle term. Okay, so let's assume that the two numbers we are talking about are a and b. Okay, so let's say let the two numbers be uppercase a and uppercase b. Then the two numbers we are looking for are such that a times b will be equal to acx squared. So the product of the two numbers we are looking for will give us the product of the first and the last term, and the sum of the two numbers we are looking for will give us the middle term bx. So that is what step 1 and step 2 of the theory is talking about, of this particular technique for solving quadratic equation, the factorization technique. Now, once you are done doing this, all you have to do is implement step 3. And in step 3, factorize. Okay? Factorize. So step 3 requires us to factorize the expression. Factorize the expression and solve for the variables. Okay, so that's what step 3 requires. Okay, so now that we have put up step 1, step 2 and step 3 for solving quadratic equations using the factorization technique, let us now go into using this algorithm for solving a problem. So come with me. Now I'm going to wipe up this. I'm going to wipe this off. So let's quickly look at how to use the technique. So now let's assume that we are given this to solve. We are asked to solve the quadratic equation. Solve the quadratic equation x squared plus 7x plus 10 equals 0. Okay, so let's assume that we are to solve this quadratic equation using the technique of factorization. The question is, how do we go about it? So the step 1 says we must look for two numbers, a and b. So we must look for two numbers, a and b, such that a times b will be equal to the product of the first term and the last term. And what is the first term? It is x squared. What is the last term? It is 10x. So the two numbers we are looking for, according to the algorithm, must multiply to give us the product of the first and the last term, meaning that it must multiply to give us x squared times 10, which is 10x squared. Okay, so that is me implementing step 1 of the algorithm. The algorithm in step 2 also says that a and b must be such that a, when added to b, must give the middle term. And what is the middle term? The middle term is 7x. So if you add the same two numbers you're looking for, a to b, you will end up having 7x, the middle term. Now the question is, how do we search for those two numbers? Now I'm going to give you a clue on how to look for the two numbers without wasting time in the exam. Now, if you are to look for these two numbers such that two of them would multiply to give the first and the last term in product, or would add up to give the middle term, I would advise you look for those two numbers in the factor of 10, okay? The factor of 10, the factors of 10. So what are the factors of 10? The factors of 10 are 1, 2, 5, and 10. Now, why are they factors of 10? These are all the numbers that can divide 10 without leaving a remainder. Now, you will notice that 1 and 10 multiply to give 10. And you will also notice that 2 and 5 would multiply to give 10. Now, searching for the two numbers you're looking for among the factors of 10 would be the simplest way to not waste time in solving problems like this using the factorization technique. So what would you do here? Now that you know that you've listed out the factors of 10, let's examine the factors of 10. Now, I'm going to put 1x and 10x. 1x and 10x, okay? Let's assume that the two numbers we are looking for are 1x and 10x. The question is, if this is my A and this is my B, do these two numbers satisfy the step 1 and step 2 of the algorithm? Let's see. Now, if you add 1x or multiply 1x by 10x, the result will be 10x squared. But do not jump into conclusions hastily. Now, you will notice that multiplying 1x and 10x gives me the product we desire. But does that actually mean that 1x and 10x are the two numbers we're looking for? The answer is a big no, because we must look for the next step. Now, the next step is that the same 1x and 10x must add up to give us the middle term. Now, the question is 1x plus 10x equal to 7x? Is 1x plus 10x equal to 7x? The answer is a big no. Okay, so 1x plus 10x is not equal to 7x. And since 1x plus 10x, the two numbers we have just searched for, do not add up to give us the middle term, it means that those two numbers are not the numbers we are looking for. So come over here. What we'll now do will be to test the other two factors of 10. So testing the other two factors of 10, what are the other two factors of 10? The two factors of 10 are 2 and 5. The other two factors of 10 are 2 and 5. So I'm going to test them also. 2x and 5x. Let's examine them. So let's examine these two factors if they meet the conditions in step 1 and step 2. So I'm going to put here 2x times 5x. What would it give us? It will give us 10x squared, which is the same thing as what we desire. Okay? Now, so if 2x is your A and 5x is your B, you will notice that A times B actually gives us the product of the first and last term. That is ax squared times c. Okay? So that condition is okay. Now let us test the next step. Is 2x plus 5x equal to 7x, the middle term? The answer is a big yes. Okay? Since 2x plus 5x actually gives 7x, then it means that the two numbers we are looking for are 2x and 5x. Now, once you do that, once you've noticed that you found the two factors we really need, what would you do? You come back to the problem. What does the problem say? Solve x squared plus 7x plus 10x plus 10 equals 0. Okay, using the factorization technique. So what I'm going to do is this. I'm going to put, in place of 7x, I'm going to put those two numbers that actually satisfy step 1 and step 2. What are the two numbers? 2x plus 5x. So I'm going to use this. I'm going to use 2x plus 5x to replace 7x. And then add 10 and equate to 0. I hope you understand what is actually going on. Now, once you get to this stage, the next stage will be the factorization stage in step 3. So in step 3, you would have to factorize. So in order for you to factorize easily, take them in groups. X squared and 2x, the first two terms, and then take these other two. So I'm going to call this one group 1, and I'm going to call this group 2. Okay? Now, you would notice that in group 1, which is x squared plus 2x, x is common. So bring out x that is common. If x is common, bringing it out will give us x into x squared is x, and x into 2x is 2. Okay? And that will give me a new group. This will give me a new group 1. And I'm going to write here, new group 1. Okay? Now, coming over here, you will find that common to 5x and 10 is 5. 5 can divide 5x and it can also divide 10. So I'm going to bring out 5x. I'm going to bring out 5 rather. And when it comes out, it gives us x. That's when 5 divides 5x, it gives you x. When 5 divides 10, it gives you 2. Now, one thing that makes you very sure that you are on the right track when solving a quadratic equation using this technique, the factorization technique, is that at this stage of the solution process, the factors in group 1 and group 2, there will be a common factor in group 1 and group 2. Notice that x plus 2 is found in my new group 1, and x plus 2 is also found in my new group 2. So I'm going to call this new group 2, okay? Now, does the problem solving process stop there? No. So, I'm going to do this. Now, I will factorize again at this stage by bringing out what is common to new group 1 and new group 2. What is common to new group 1 is x plus 2. I will bring it out. If I bring out x plus 2 from here, I will be left with x. So I'm going to put x I'm left with in another bracket plus bringing out x plus 2 from this new group 2 will leave me with 5, and I'm going to have 5 here, and the product will be equal to 0. Okay? Now, at this point in time in the solution process, implement this rule of algebra that if A times B is equal to 0, if the product of two numbers are equal to 0 or is equal to 0, then it is either the first is equal to 0 or the second is equal to 0. Okay? If A times B is equal to 0, then A is either equal to 0 or B is equal to 0, but not both of them at the same time. Now, it means that x plus 2 is equal to 0 or x plus 5 is equal to 0. So, this is a product of two numbers. So, a product of two numbers equal to 0 means that either the first is equal to 0 when the other is not, or the second is equal to 0 when the first is not. And this would mean, solving for this would mean x will be equal to minus 2 when it comes over here. And x plus 5 is equal to 0 implies that x will be equal to minus 5. Now, this will be the solution to the quadratic equation. Okay? So x equals minus 2 and x equals minus 5 are the solutions to this quadratic equation. Okay? Now, let's test. Let us quickly run a test to see whether those two roots are solutions to the quadratic equation. Let us quickly do a test. Now, we are going to check if our solutions are in order. So I'm going to write here, check. Okay? In order to check, put minus 2 into x squared plus, so I'm going to substitute for x equals minus 2 into x squared plus 7x plus 10. Now, if x minus 2 is indeed a solution to the problem, it will reduce this equation to 0. It will reduce the equation to 0. So let's see. If I put in place of x minus 2, this will become minus 2 squared. And this will become 7 times minus 2 when I put minus 2 in place of x, then added to 10. So let's see what it gives. Minus 2 squared is 4. 7 times minus 2 is minus 14, and then added to 10. This will give us 4 minus 14 is minus 10, added to 10, this gives 0. So it means that x equals minus 2 is indeed a root to this problem. Again, you can also test by substituting for x equals minus 5. Okay? If you substitute for x equals minus 5, you would also see the same thing. Now, x squared plus 7x plus 10 equals 0. Put in place of x minus 5, x minus 5 squared plus 7 times minus 5 plus 10. Let's see what it gives. Minus 5 squared is 25. 7 times minus 5 will give you minus 35. Then plus 10. Okay? This will be equal to minus 25 minus 35 will give me minus 10 plus 10. This reduces again to 0. So you would notice that this technique is simpler to use only when you know those two numbers whose product will give the product of the first and the last term, and whose sum will give the middle term. Okay? Now, what do we call the roots? What do we call these solutions? These solutions are called roots to the equation. So x equals minus 2 and x equals minus 5 are roots of this quadratic equation. So if you don't want to call them solutions, you call them roots to the quadratic equation. Another thing you must know is that a quadratic problem, a quadratic equation would always have two roots or two solutions. And the reason why that is so is because of the power. A quadratic equation has its highest power as 2. So when solving a quadratic equation, you would be expecting two roots. That being said, let us go to the next technique. Okay, so now let's move over to the next step, like I said earlier on. For the next step in solving quadratic equations, or the next technique for solving quadratic equations being the completing the square method, this particular technique will help you overcome a challenge you may encounter using the trial and error method. And what is that challenge? It will take you time, in most cases, to always think of those two numbers that will add up to give you the middle term, but multiply to give you the product of the first and the last term. So instead of wasting so much time looking for those two numbers, the technique of the completing the square method and even that of the quadratic formula would help you overcome that challenge. So let us look at the second technique for solving the quadratic equation. So this technique is called completing the square. Completing the square technique. Okay? The completing square technique. Now, this particular technique requires one simple principle, and I'm going to explain this soon enough. So, what is the technique all about? The technique states that the number to be added to make an incomplete, the number to be added to make an incomplete quadratic expression complete must be the square of half the coefficient of the linear variable. Okay? So, the technique states that the number to be added to an incomplete quadratic expression to make it complete, must be half the square of the coefficient of the linear variable. So I'm going to be using this particular technique to explain how to solve a quadratic equation. Okay, so let's look at it from this angle. let's bring up that problem again. So the problem we solved earlier was the problem x squared plus 7x plus 10 equals 0. Now, if you don't want to use the trial and error technique or the factorization technique or the scissors method technique for solving quadratic equations, you can use the completing the square technique. How do you go about using this technique? All you have to do is just to understand this simple rule that the number to be added to an incomplete quadratic expression to make it complete must be the square of half the coefficient of x, and then simplify. Now, one other thing you must know here is that in solving this quadratic equation using the completing the square technique, you must understand how to work with simplification of algebraic problems. So let us see. Now, the first thing I'm going to do is to make this quadratic equation incomplete. If you watch the first episode, you must have heard me say something about an incomplete quadratic expression. So I would want you to watch that video to see what an incomplete quadratic expression really is. Now, this is what I'm going to do. I'm going to make this quadratic equation incomplete by taking away this term, the last term. So when I do that, I would have x squared plus 7x equals 0 minus 10, which is minus 10. Okay? So the first step to using the completing the square method is to make the quadratic equation incomplete. Okay? So I'm going to put that as my step 1. Okay? Make the quadratic equation incomplete. Okay, so when is a quadratic equation incomplete? A quadratic equation is mostly incomplete when it lacks the constant term. So the constant term in this case is 10, and you have x squared plus 7x plus 10 equals 0. So if you omit 10, the constant term from a quadratic equation such as this, it becomes an incomplete quadratic expression. So the first step to solving quadratic equations using this method of completing the square is to make sure that you make the quadratic equation incomplete. So once that is done, the next thing you would do is step 2. Okay? So in step 1, you make the quadratic equation incomplete by taking away the constant term from the right-hand side, from the left-hand side to the right-hand side, and then in step 2, you would implement the completing the square rule. Implement the completing the square rule on the simplified version of your quadratic equation. Now, what do we mean by the simplified version of your quadratic equation? In using the completing the square rule, you must ensure that your quadratic equation just after step 1 is simplified. What does that mean? I'm going to generalize what I'm saying here in this step. What that means is that the coefficient in the simplified version must have, the coefficient of the quadratic variable in the simplified version must have 1. Okay? If there is a coefficient greater than 1 here, it must be used to divide through. Okay? So that 1 will be the simplified version. So in step 1, you make the quadratic equation incomplete by taking away the constant term. Okay? And in step 2, you implement the completing the square rule. What is the completing the square rule? It says that the number to be added to make an incomplete quadratic expression complete. The number to be added to make an incomplete quadratic expression complete. So I'm going to remove this. Okay? Complete must be the square of half the coefficient of the linear variable. So once we've done that, we will come over to step 2. Now in step 2, we now have x squared plus 7x equals minus 10. Now, according to the rule of completing the square, I have to take the coefficient of this one out, that is the coefficient of x, the linear variable. X is the linear variable, x squared is the quadratic variable. So if you take the square of half the coefficient of the linear variable, that must be added to both sides, okay? So what is the linear variable? It is x. What is the coefficient of the linear variable? It is 7, okay? So since the rule says add the square of half the coefficient of x, I'm going to start with dividing the coefficient of x being 7 by 2 and then squaring it. So the square of half the coefficient of x is obtained by dividing 7 by 2 and then squaring the result, and that will give you 49 over 4, okay? 49 over 4. Now, just after getting this result, you will now bring them over, adding to the left-hand side x squared plus 7x, 49 over 4, which is the square of half the coefficient of x, and then you will now add to minus 10 on the right-hand side, 49 over 4, the same thing. Now, once you do this, because you have done this by adding 49 to 4, over 4 to this incomplete quadratic expression, it now makes it a perfect square. What is a perfect square? It is a number obtained from the product of two similar numbers. Now, because you have added the square of half the coefficient of x to x squared plus 7x, it automatically means we can write x squared plus 7x plus 49 over 4 as x plus half of this linear variable, all squared. That is 7 over 2 all squared. So this result on the left hand side reduces to this, and that will be equal to minus 10 plus 49 over 4. Okay? Now, what is minus 10 plus 49 over 4? It will give me the LCM 4, and this is 1. 1 into 4 is 4. 4 times minus 10 will give me minus 40. 4 into 4 is 1. 1 times 49 will give me 49. And when you add 49 to minus 4, the result you get is minus, the result you get is 9 over 4. So we will now come over here to complete the problem, okay? So now that we have gotten that x plus 7x, 7 over 2 all squared equals 9 over 4, let's bring the problem over here. So I'm going to write x plus 7 over 2 all squared equals 9 over 4. At this stage of the problem, the next thing you must do will be to take the square root of both sides. So take the square root. Take the square root of both sides. Okay? So when you take the square root of both sides, you will end up having the square root of x plus 7 over 2 all squared equals plus or minus the square root of 9 over 4. Now, because it is a quadratic equation, we should be expecting two roots, and hence the reason for the plus or minus. More so, another reason for the plus or minus is that whenever you take the square root of a number, you should know that there are two possible solutions, because the product of two positive numbers will give you the same result, the same way the product of two negative numbers will give you the same result. So plus or minus square root of 9 over 4 is what we are expecting. Now, what would you have here? The square root of the square of a number will give you the number, so this will be x plus 7 over 2. And this will be equal to plus or minus, the square root of 9 is 3, and the square root of 4 is 2. Okay? Now, if you simplify further, you will end up having x equals minus 7 over 2 plus or minus 3 over 2. And this will give us LCM is 2. Minus 7 comes here, and plus 3 comes over here, because 2 into 2 is 1. 1 times minus 7 is minus 7. And 2 into 2 is 1. 1 times 3 is 3. So this gives you minus 7. Minus 7 plus or minus 3. Okay? Now, there are two possible ways this result can go. It can go the way of minus 7 plus 3 over 2, or minus 7 minus 3 over 2. In this case, minus 7 plus 3 would give you minus 4. And when you divide minus 4 by 2, you end up having your result to be minus 2. And it is possible to also have minus 7 minus 3, which is minus 10, and minus 10 divided by 2 will give you minus 5. The same result we got using the technique of factorization. So you can actually use the method of completing the square by using the steps I have provided, and you will get your result. The same root, minus 2 or minus 5. Take note, the reason why we'll be using the completing the square method is because the trial and error method or the factorization method would always make you think of two factors whose product will give you the first and the last term, and whose sum would also give you the middle term. So this technique is somehow faster in usage than the technique of the factorization method. Now let's go over to the last method. So the last method is the technique of the quadratic equation, otherwise called the almighty formula. And I've told you, I still do not know why it is called the almighty formula, because there are so many formulas mightier than it in complexity. But it is called the technique of the quadratic formula or the almighty formula. So let us see how this technique is used. But the first thing I'm going to show you is how to develop the almighty formula or the quadratic formula from the completing the square technique. So come over with me. Now, so we shall look at the quadratic formula. Okay, the technique of the quadratic formula. I'm going to call it the quadratic formula technique. Okay, so what is the technique all about? Okay, let ax squared plus bx plus c be equal to 0 be a quadratic equation. So this is a quadratic equation, certainly by what we've defined a quadratic equation to be. Now, using the completing the square technique, we can start with implementing our step 1. What was our step 1? It was to make this particular quadratic equation incomplete. So I'm going to make it incomplete by taking c to the other side, and it becomes minus c. Okay? So if you are to use the quadratic formula, I would love you as a student to know how to obtain the quadratic formula. The quadratic formula is an extension of the completing the square technique. Okay, it is obtained by an extension of the completing the square technique. And how is that done? The first step in the completing the square technique was to make the quadratic equation incomplete. And how do you make quadratic equations incomplete? Remove the constant term. That is, take the constant term away from the left hand side to the right hand side, and it becomes incomplete. A quadratic equation that is incomplete lacks the constant term. So that is what we have done. Okay, so c brought over here becomes minus c. It is the same thing as subtracting c from both sides. So if you move c from this side to this side, it means subtracting c from this gives you 0, and subtracting c from 0 gives you minus c. So that's what we've done. So what will be the next step in obtaining the quadratic formula? After doing this, if you remember what I told you in the completing the square approach, I told you the next step would be to get the simplified version of this step. Okay, the simplified version of this step requires that you must divide through by the coefficient of x squared if it is not 1. The coefficient of x squared must be 1, okay? If it is not 1, you must make it 1 by dividing through by the coefficient of x squared. So what is the coefficient of x squared? It is a. So the next step I'm going to take will be to say ax squared divided by a plus bx divided by a is equal to minus c divided by a. Now once you do this, a would cancel a, giving us x squared plus b over a x, okay, plus equals minus c over a. Okay, so what I've done here is to make a simplified version of this equation. So the next thing to do at this point will be, now that we've gotten the simplified version of this equation, we are now going to implement the completing the square rule. So what does the completing the square rule say again? It says that to make an incomplete quadratic expression complete, one must add the square of half the coefficient of x. You will notice that half the coefficient of x is b over a, and the square of b over half the coefficient of x is b over a times 1 over 2. So half times b over a gives us b over 2a. This is half the coefficient of x, because the coefficient of x is b over a. Now when you square this, according to the completing the square rule, when you square this, you would have to square this, and that will give you b squared over 4a squared. B squared is this, 2 squared is 4, and a all squared gives you this. So this is what we must add to this incomplete part of the quadratic equation to make it complete, and we have to add it to the other side, of course. So this will be x squared plus b over a x plus b squared over 4a squared. Okay? Now I'm going to equate this. I'm going to equate this result to this other side, minus c over a with b squared over a with b squared over 4a squared added. Okay? So this is what I'm going to get. Okay? Now let's come over here to continue the problem. To continue the problem, we now have this. For the left hand side rather, now that we have added b squared over 4a squared to this incomplete part of the quadratic equation, automatically that becomes a complete square, and a complete square is a perfect square. So I can now write x plus half of the coefficient of x, which is b over 2a. So b over 2a squared is the representation of this, identical to that, okay? And that will be equal to minus c over a plus b squared over 4a squared. So taking the LCM of a and 4a squared will give us 4a squared. A into 4a squared will give us 4a. So 4a multiplies c to give minus 4ac. 4a squared into 4a, a squared will give us 1. 1 times b squared gives us b squared, which can be written as b squared minus 4ac all over 4a squared if you reverse the problem, okay? Now, I will bring this down. X plus b over 2a all squared, x plus b over 2a all squared. And that will now mean taking the square root of both sides will leave me with x plus b over 2a here equals plus or minus the square root of b squared minus 4ac all over 4a squared. Now, according to sorts, the rule of sorts, the square root of a over b is equal to the square root of a all over the square root of b. And I'm going to use this technique here. Okay? So if I use this technique here, this would give me square root of b squared minus 4ac all over the square root of 4a squared is 2a. And this will give me x plus b over 2a. Okay? If I make x the subject of formula, I'm going to have b over 2a minus b over 2a, sorry, plus or minus square root of b squared minus 4ac all over 2a. And that gives me my final result, x equals minus b, because the LCM is 2a plus or minus square root of b squared minus 4ac. So this is the quadratic formula. Minus b plus or minus square root of b squared minus 4ac all over 2a is the quadratic formula. So let's use it to solve that same problem, and we shall end our video. Okay? So I'm going to come over here now and use it to solve that problem. What was the problem again? We were to solve x squared plus 7x plus 10 equals 0. So the quadratic formula says the root to this equation will be minus b plus or minus square root of b squared minus 4ac all over 2a. So what is your a? Your a in this formula is the coefficient of x. Okay, your a is the coefficient of x. So I'm going to take a equals 1 because the coefficient of x is 1. Your b is the coefficient of x, your a is the coefficient of x squared, so I'm going to take a to be 1 because the coefficient of x squared is 1. And your b is the coefficient of x, okay, the linear variable, so I'm going to put b equals 7 because the coefficient of x, the linear variable, is 7. And your c is the constant term, which is 10. So once you have a quadratic equation and you intend to use the quadratic formula, which is the fastest method for solving a quadratic problem, is what you have to do is to take out all the variables, okay? So a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So taking that out from your quadratic equation, let us obtain the root. This will be minus whatsoever b is, which is 7, minus 7, plus or minus the square root of b squared, 7 squared, minus 4 times whatsoever a is, and a is 1, whatsoever c is in multiplication, which is 10, all over 2 times a, which is 2 times 1. And that gives you minus 7 plus or minus square root of 49 minus 40 all over 2. 2 times 1 is 2. And this gives you minus 7 plus or minus the square root of 9, because 49 minus 40 is 9 all over 2. And this will result in minus 7 plus or minus the square root of 49, the square root of 9, which is 3 all over 2. Okay? Now, simplifying to get your final result, you would notice that x would be equal to minus 7 plus 3 over 2, or minus 7 minus 3 over 2, which simplifies to give minus 7 plus 3 is still minus 4 over 2, which is minus 2, or x can be minus 7 minus 3, which is minus 10 divided by 2, giving you minus 5. The very same result we got using the previous techniques. If you like this video, please smash a like on the video, subscribe to the channel by clicking the subscription button, and endeavor to follow our channel by watching out for videos we upload and streams we make. Okay, do well to drop your comments. I would really appreciate your comments. Tell me how you see what we have taught. Tell me how all your challenges are, and I'll be seeing you in the next episode on this class of Theory of Quadratic Equations. Thank you very much.